Here in Module 3, we're looking at fractions, more specifically fractions that involve a polynomial in the numerator and a polynomial in the denominator. A fraction like that is called a rational expression. In Module 3, we're going to take the whole module just to discuss fractions, discuss rational expressions and operations on rational expressions in preparation for Module 4, where we look at properties of rational functions, an extension of this Module 3 topic. So let's take a look, starting here in example 1 with a fraction, a rational expression, y squared plus 10y plus 25 over y squared plus 11y plus 30. And the idea here, what we want to do is simplify that rational expression. And when you're given a fraction and you're asked to simplify that fraction, if it's just a single fraction, there's nothing much to do other than that division bar, then what we should automatically be thinking is, can I reduce the fraction? Are there any common factors in the numerator and the denominator that I can reduce? And when I say common factors, I don't mean the y squared in the numerator and the y squared in the denominator of this fraction. Those are not factors. Those are not factors because they're part of a polynomial. They're part of a sum or difference of terms. So I can't cancel the y squareds here because they're like terms. No, I have to cancel common factors, and that's the key word there, factor. And that's the first step I should be thinking. Can I factor the numerator and factor the denominator? And a lot of what we do in this module and the next with rational functions is going to involve factoring. We talked about factoring in Module R, so if you need to go back and review your factoring from Module R and ask in the tutoring lab or one of my live sessions, then I highly recommend it. Here, if you factor the numerator and factor the denominator separately, you should get y plus 5 times y plus 5 in the numerator and y plus 5 times y plus 6 in the denominator. And now we're looking for common factors, and I see that with y plus 5 in the numerator and y plus 5 in the denominator. Those factors cancel, they reduce, and what I'm left with is y plus 5 in the numerator over y plus 6 in the denominator. Once again, these nothing else in these polynomials, the numerator and denominator, reduces, even though you could say, well, they both have a y. Yes, they both have a y term, but not a y factor. And you got to see the difference there. Ask questions if you've got them, but that is our most simplified answer here, y plus 5 over y plus 6. And here again, we have another rational expression to simplify. Same ideas as example 1. The only difference here is that the polynomials involved are take a little more work to factor, especially when you've got the larger numbers involved, and especially when you have larger values of a, that leading coefficient, where in the numerator we see that a is 12, and in the denominator we see that a is 28. And in that case, we have to use, well, we have other factoring techniques that we can use that we also reviewed in Module R. The one that I called the AC method, multiplying A times C and finding those factors and splitting the middle term. Let me just do a quick walk, since we've already covered that in Module R. Let me just do a quick walkthrough of what that looks like in this example. Let's take the numerator first over here in our scratch work to the side. A times C is 12 times negative 8, which gives me negative 96, and I split negative 96 into factors, and I'm looking for a pair of factors that add up to negative 29, and I find that with negative 32 and positive 3. Multiplying gives me negative 96, and adding those two numbers gives me negative 29. Similarly, in the denominator, a times c for the AC method is 28 times negative 3 is negative 84, and I'm looking for factors of negative 84 that add up to negative 5. And I ran out of space on my slide here before I found those factors. So as I continue finding factors, what I find is that negative 12 times 7 gives me negative 84, and negative 12 plus 7 is negative 5, the middle term there in the denominator. So I found my pairs of numbers that work, numerator, denominator. Let's do the factoring, kind of do it simultaneously for both numerator and denominator, where I split the negative 29n in the numerator into negative 32n plus 3n, and the negative 5n in the denominator to negative 12n plus 7n. You don't have to do both factorings at the same time. If you want to do your scratch work for one and then the other separately and then put it back together, if that is more comfortable for you, easier to follow, easier to wrap your mind around, absolutely do that. Saving a little space on my slide here by doing the factoring both of them at once, and that's okay with me. So here, as I finish factoring by grouping the first two terms and the last two terms in each one of those and factoring what they have in common, I see I've got 4n times 3n minus 8 plus 1 times 3n minus 8 in the numerator, and then 4n times 7 minus 3 plus 1 times 7 minus 3 in the denominator. Finish factoring by grouping, and we have 4n plus 1 times 3n minus 8 in the numerator, and 4n plus 1 times 7n minus 3 in the denominator. And I've got common factors that now reduce 4n plus 1 in the numerator with 4n plus 1 in the denominator. And what I have left is 3n minus 8 over 7n minus 3, and that's in simplified form.